Right, hello everybody. So I'm just letting everybody join the call just to make sure that everybody can hear me fine as well. So just to welcome everybody, and I'll just continue admitting people in for the next 5 minutes or so, so that everybody can. Okay, so just to say hello everybody, it's Josh here just to say hi and thank you very much for joining my second workshop for Space4All, where today we'll be looking at how to identify the planets. So it's really exciting, and I'm just going to leave about 5 minutes or so before we begin, just so that it's fair for everybody. So just in case you guys are wondering, we're live now on Facebook and YouTube, so that if anybody's watching on those platforms, that will give people a chance to watch via social media as well. And just got a couple more people joining in. That's nice. A good turnout as well. So I just want to say thank you very much for your guys' support. It does mean a lot. So we'll just wait for a couple more people to join. So just to discuss what we're talking about for this, guys, we'll be talking about how to identify the planets of our solar system, what planets we can currently see in the night sky, and how to identify them with your unaided eyes and optical aids such as telescopes. So just in the background, I'll just mention this later on in the presentation as well. If I could ask for everybody, for the meantime, just to mute themselves for the purposes of this presentation. And feel free to keep your cameras on because I love to see all of you guys along the top of my screen. So that is lovely. And just continue adding a couple more people. Okay, which is looking good. There we go. It's always the fun with technology such as Zoom. It's always lovely to see everybody join. Unfortunately, guys, I would have loved to have done tonight's workshop as a real-time live workshop. But unfortunately, for you guys who may not know that when it comes to astronomy, we need a clear sky. But guess what? Here in England, unfortunately, the weather is atrocious. It's very heavy cloud. So this is like the best contingency in order to do the workshop. So I can just hear a little bit of background noise. I'd just like everybody to check, please, if they could mute themselves, just for the purposes of this presentation. And I hope to begin at around 5 minutes past 7. So I hope all you guys have been doing well since my last workshop. And when we've had these little gaps in the night sky that we've been able to see the major constellations of the night sky. So I'm really glad with all the feedback which I've had, and just to say thank you again for my support, and I hope that my previous workshop was of use in order to identify these constellations. So what we're doing now, going on from the major constellations, is to divulge that little bit further into the universe. So now we're going to be looking at the planets, the major objects of our solar system, our place in space. So very quickly, just whilst I leave these next couple of minutes, I'll just transfer my screen over to the presentation, just to leave enough time. Okay, so please excuse me just 1 minute as I get myself sorted out. Lovely jubbly, this is great. So just wait for that one to load. Okay, so we've got a number of different people from around the world joining this evening, which is lovely. So I'd like to say hello to my friends who are my astronomers joining the call, and I can see some of you guys here, so hello. And some of my friends also from the International Dark Sky Foundation, so that is really great to see, and thank you again. So no, this is really good. Okay, so what time are we on now? We're on 4 minutes past. So if anybody else joins the call, I will begin adding people then as well. So just as a confirmation for me, because I can't hear your guys' lovely voices, just give me a thumbs up to your screen just to make sure that you can hear what I'm saying and you're ready for a mad hour of astronomy madness. Yes, great. Okay, so I think I've realised now that I'm on the wrong slide of my presentation. So please excuse me, because that is meant to be the end. So give me 1 second, please. Right, here we go. Okay, so thank you for your guys' patience there. So, as I've talked, just whilst people have been joining the call, we'll be looking at the planets this evening. So again, say thank you for joining my second workshop with Space4All, and I hope this workshop will benefit you when we next get a clear sky under the current lockdown restrictions, and we can keep connected whilst looking up at the night sky. Okay, so for those of you who are new to Space4All, all my new members, I'd just like to say thank you very much. So in case you haven't heard what Space4All is about and what this lovely logo is about, I'm here to promote practical astronomy and to engage members from all backgrounds. So wherever you may be in the world, wherever you have a casual interest in the stars and the night sky, I'm here to deliver that interactive, engaging experience for you guys in order to look up at the night sky. So I'll be teaching the basics of astronomy and stargazing, and doing so being able to recognize the importance of light pollution and mega satellite constellations, which are currently impacting the way we view the night sky. And as I've reiterated, in my previous workshops, that I'm wanting to realize the importance of connecting all of us during lockdown, and how important it is to look up at the night sky during these unprecedented times, even though they're changing. So we'll keep an eye on that. Okay, so just some final instructions then before we begin the main core of my presentation. So if I could please ask for everybody to mute themselves for the purposes of the workshop, just so that we don't get any interfering sound, and then I'll be able to present this to you in as clean a possible way as I can. And if anybody has any questions, please feel free to use the chat. Just make sure to begin your question literally with the word question. So when we get to the end of the presentation, I'll be able to filter through those for you and answer all your lovely questions. Otherwise, please use the raise your hand tool. So this gives you a chance to speak if you so wish. So that's all of just the quick instructions over with. So we'll get on with the core of the event. So the planets are placed within the solar system, which you can see with the unaided eye and beyond. I purposefully wanted to mention this in this particular workshop because you don't need a telescope to see the planets of our solar system necessarily. However, there may be some where you are required to use a telescope, but this will be where you can advance in your astronomical journey. So for those of you who will know astronomy quite well, you'll be wondering, we know who this guy is, but for those of you who don't know, this is a pioneer in the world of astronomy. So as some of you guys might already know or have a good idea, this is Galileo Galilei. And in the year 1610, he uncovered one of the most important perceptions of looking up to the night sky and our astronomical endeavors. He looked up to the planets, where he was able to identify at this moment in time the planet Jupiter. And day on day, whenever he had a clear sky, he observed with his homemade telescope the movements of what are known as the Galilean moons. And these are the major moons which orbit around the planet Jupiter. So he was a pioneer. He was amazing in the sense that he translated our way in which we observe the foreseeable universe. So really, when we look at the planets, we're seeing some of the most important discoveries, I believe, made in astronomy and realizing this place in the universe. So just remember this during the workshop on how astronomers used to document our place in the universe. It's fascinating to see. Right then. So we will begin with the innermost planet of our solar system. So this is the planet Mercury. And just for those who are unaware, the planet Mercury is, of course, the closest planet to our sun, our local star, the sun. and in doing so allows astronomers to observe this particular planet either at sunrise or sunset. So I think this is a very important way to look at the innermost planets of the solar system, because it's all to do with our perception of the solar system. So any of the planets which are closer to the sun will either appear just before sunrise or after sunset. So what I have done, as you guys can see in the lower left of your screens, is I have made a note of some dates of when you are able to best see the planets of the solar system this year. So if you guys want to take a look and try and have a look for these objects, then is a good time to have a look. So I'll just run you through a couple of those, in the sense that in order to observe the planet Mercury this time around, you want to be looking between the 3rd and the 24th of May. And this is when, during its orbit, it will appear, excuse me, during the evening hours, so just after sunset. However, between the 18th and the 1st of November, we'll be able to see this object in the morning skies. And just to run through some of the statistics, looking at this beautiful image from NASA, is that this particular planet, Mercury, doesn't have any moons. So realistically, what we're looking at here is a solid cratered surface, one of the hottest planets of the solar system, but it's not the hottest, and we'll get onto that in just a second. And just to mention as well that there's a term used for these innermost objects, which is called greatest elongation. I know, what is this mad term that Josh is on about here? So greatest elongation is the highest point in which we're able to observe the innermost planets of our solar system. So on the dates which I've mentioned, just in the lower right is when you'll be able to see them at their highest altitude. So in this case, we've just missed the most recent elongation, which occurred on the 24th of January. And now, upcoming event will be on the 6th of March. So this is one, if you guys have got your pen and paper at the ready or you're taking notes, just make sure to make a note for the 6th of March. This will be a really good time to try and look for the planet Mercury. And I'll also make a note as well about the brightness of these objects. I think this is another important way to realize what we're looking at here, because the planets are all dependent on an astronomical term known as magnitude. And this is all depending on the brightness of an object in the night sky. So as you can see, just in the bottom part of my screen, you see the word mag plus 0.36. So just to give you an idea of what magnitude means, plus, this has always been the way I've remembered it since I was 7 years old, so just bear that in mind, but plus usually tends to mean a dimmer object, okay? So when we see plus, it means it's getting a bit too faint for the unaided eye, so we're going to have some difficulty seeing those objects. And I can tell you that as astronomers, we can observe to around a magnification, or magnitude rather, of 6.5. So as you can imagine, in terms of magnitude 0.36, that Mercury will appear as a relatively bright object just after sunrise, or before sunrise rather, or just after sunset. Whereas if you get magnitude of objects in minus figures, they appear super, super bright in the night sky, and they're very easy to see. So that's just worth bearing in mind throughout the talk. So I can understand that may be a bit complicated just at first, for those of you who may wish to learn more about the stars. But if you've got any complications at all, please feel free to use the chat, and there I'll be able to help you with that as well. So whilst I just sort this out, just excuse me 1 second, please. Just see what's happened here on the workshop. Please excuse me for 2 seconds. Here we go, we're back, lovely. So as I was trying to say, if you guys have got any questions, please make sure to use the Q&A tool if you found any of that complicated, and I'll do my best to explain at the end of the presentation. This is important as well. So this little thing crescent is how we're currently seeing the planet Mercury now on the 24th of February, just after 7 o'clock. So I'll just reiterate that these images are not to scale. However, they're here to demonstrate what you are able to see currently if you were to observe the planet Mercury. So again, a very solid cratered surface, and that is the best way of describing what you're able to see on the surface of this world. And just like our own moon, and with one more planet in just a minute, we're able to see the change in phases of the planet Mercury. So again, that's something to look out for if you wish to look up at the stars or the night sky. But in order to see the crescent shape, you will need a telescope of sorts. So it doesn't matter what size or what eyepieces you may have, you should be able to identify the changing phases throughout the year. Okay, the next one, the planet Venus. Now, this is a super, super bright object, which I've seen with astronomers in the past. So, as you guys can see, I've changed the magnitude on this one to minus 3.90. So this is how Venus currently appears in the night sky. So already, if you can imagine from what I was saying earlier, when we can see stars just about to the edge of plus 6.5, Venus is super bright and you can't miss it again, either just before sunrise or after sunset. So again, is another one of those objects when you can use your unaided eye and use optical aids such as binoculars and telescopes to observe the surface of this world. So I've just made some notes here as well, and just to describe what we're looking at here when we observe the planet Venus. So if you imagine that when you're looking at the surface of this world, you're in fact not looking at the surface at all. You are looking at a very highly reflective, cloudy atmosphere, which is a toxic atmosphere, and most importantly, is made of carbon dioxide and sulfuric clouds. So if any of you guys have got the idea of taking a trip to Venus one day, don't do it, because the temperatures there are so hot. In fact, they are the hottest in the solar system. I believe it's around 400 plus degrees centigrade. Please correct me if I'm wrong there, but it is one of the hottest planets in the solar system. It is unbearable to live on. So even though when you're looking through your eyepiece or looking up on a nice clear night and you're looking at the planet Venus, you're actually seeing quite a hot world, and quite a violent one too, for that matter. So again, just a couple of dates of when is a good time to observe this world. That between the 1st to the 23rd of January was a good time to see it in the morning skies, but realistically, because it will be close to the sun for a period of time, you want to be trying to look at around the 24th of May to the 31st of December, and this is when it will begin to appear in the evening sky. So again, this planet doesn't have any moons, and its greatest elongation, which is the highest it will appear in the sky, will be around the 29th of October. So then will be a really good time to have a look, and you'll be able to see it very clearly in the night sky for a long period of time. So moving to our next slide. This is how we would see Venus at the minute. So when I talk to you about this very thick toxic atmosphere, we'll be able to see a full round disk. And I believe also if you use particular filters, and I even believe a couple of color filters, such as red, green, and blue filters, which, just to explain to you, are used to attach to eyepieces and then into your telescope, can help astronomers see so many different details, so much so you'll be able to see some of the cloud structures on Venus. And again, the changing phases throughout the season. So Venus is definitely a planet to have a look at. You can see so many changing features, and also the crescent phases as well, just as with the planet Mercury. So again, is a really good object to look at as well. So you probably just realized, hold on a minute, where's the next planet in the solar system? So we have Mercury, we have Venus, and then, hold on a minute, I thought Earth was meant to come next. For the purposes of this workshop, I'm sure you guys can guess that I have not included the planet Earth as one to be looking at, because we are here on planet Earth. We're looking up to the solar system. So following on from our planet is the next planet, my personal favorite, which is the planet Mars, the red planet. In fact, this was the planet which got me into astronomy a long time ago when I was 7 years old, when I used to look at science fiction stories about the planet Mars. And I got my first telescope and I looked at the surface of another world. And honestly, this is probably one of my most favorite objects, I'll be honest. So going into my notes then, what gives Mars this really reddish appearance that we see in this beautiful image by NASA? So really, it's a surface of iron dioxide. So as you guys can imagine, when you see rust on the surface of objects, what color is it? It's a reddish tinge. And this is all to do with how this planet, the planet Mars, once reacted with the elements of our solar system in a time really before, when the planet Mars had an atmosphere. This planet was very much like Earth many years ago. However, due to theories of potential global warming, just like what's happening now with the planet Venus, we see an extinct world. So this is honestly a very exciting place where through a telescope, we can see the polar ice caps, which I believe is frozen nitrogen. And we can see the dust lanes on the surface. So already in this image, you can see the varying colors of reddish hues and just streaks across the surface of the red planet. But also, one thing I always love to tell people is that you can see one of the largest volcanoes in the solar system on the surface of Mars. So much so, in the recent opposition, I'll get onto that term in just a minute, which happened last year, I saw this largest volcano. And for those of you who may be interested in what this volcano is called, it's called Olympus Mons and is the largest extinct volcano in the solar system. So when you're looking through either the unaided eye or with an optical instrument like binoculars or telescopes, you'll be able to distinguish this reddy hue. But it's when you use larger optical instruments, and I'll probably say in a region between 4 to 8 inch diameter telescopes, where you can see this exciting detail, and you compare to the surface of another world, and you can see the ice caps, you can see the dust lanes. And honestly, it's, I think, probably one of the best planets for observing a great amount of details. So when can you observe Mars? You want to be looking from around the 24th of November to the 31st. And I mentioned this term opposition, okay? So this is very similar to greatest elongation, but it's slightly different to that. So in the case of Mars, this is the closest when the planet Mars appears to Earth. It's a closest approach to Earth in its orbit. And as it does so, its diameter, its physical appearance looks a lot larger and is so important for us to observe these surface features. And this will occur on the 28th of December, 2022. And I know some of you guys may be thinking, Josh, why are you telling me this information when it's next year? But you've got to remember, because of its varied orbit, in order for it to get from one position to the next, it takes a period of 26 months. So if you think about that in terms of timescales and how long it takes for the planet Mars to orbit around the sun, this will be the next time for astronomers to be able to observe Mars at its best. So just some quick details to go through as well, just to quickly move on. There are 2 major moons, Phobos and Deimos. And so there are some very interesting names. I know they're a bit wacky, but in particular with these 2 moons, there are some very unusual moons because actually they resemble the characteristics of asteroids, very rocky, undulated objects, which apparently orbit around the red planet. So currently, this object, Mars, sits at a magnitude of plus 0.85. So, you know, it has the appearance of a star at the minute, and I can tell you it's near to the constellation of Taurus, if you guys are interested to have a look at. But I'll go into more information just exactly on how to identify those planets particularly and where. So if you were to observe Mars tonight, this is the kind of view you would have. So as you can see, just in this scaled projection or simulation, you can see some of that varied color and contrast on the surface. But you view those surface hour on hour, day after day, and you see those surface features change. And that is what I think is so brilliant about this object, the planet Mars, because there's just so much you can see as long as you see it at the right time of year. All right then, so the planet Jupiter, the king of the planets. This is the largest planet of the solar system, and is quite amazing because really, when you look at the surface of this world, your soul is made of clouds and storms. So when you imagine this and you're looking at the planet Jupiter, you're looking at really the surface features of ammonia and water, but the atmosphere itself, for those of you who are a bit more techie and a bit more into your science, the atmosphere is made of hydrogen and helium. So when you're looking at these stripes, we'll call them for now, you're really seeing some supermassive storms kicking off on the surface of the largest planet in the solar system. So how cool is that? If I'm to tell you guys that the more defined lines or stripes which you see on the surface of Jupiter are actually called the northern and southern equatorial belts. And I remember when I was very little, probably around 10 years old, I actually saw the lower belt disappear for a number of, I believe it was weeks, even months. So it's amazing that when you have a telescope and you look up to these objects, you can see the surface of these planets change. And that is what really puts into perspective that we are here on a ball of rock in the surface of our solar system. Things are happening and it's so exciting. And the most iconic surface feature of them all, which you can see in this image from NASA, is the Great Red Spot. So this really is a massive superstorm kicking off on the surface of the red planet, which has been, not the red planet, sorry, the largest planet, Jupiter, and has been going on for so many years. And astronomical research also suggests that the surface of this great red spot is actually shrinking with time. So if you want to see one of these major surface features in the solar system, guys, make sure to get looking now, because now is a really good time to look for it. And I'll go into more details later of how exactly you can observe this particular feature on the surface of Jupiter. So currently, Jupiter is shining at a magnitude of -1.96. So we'll say -2 for now. So it's bright enough to be able to see just before sunrise or just after sundown, say, just for purposes of magnification or magnitude. But it's a bright object to see, which is so important because you can see it with your unaided eyes. And again, when you use a telescope, you'll be able to observe these surface features. So again, a good time to see this is from the 8th of August through to the 2nd of September. So this will be when Jupiter will be best visible in the evening sky. And this is really a good time I recommend to observe to observe Jupiter, because it's easy for astronomers to observe, I believe, during the early evening. So that's why I've set to those dates. Now for the moons, I've purposefully demonstrated only four of these moons, but remembering that these planets have many more moons. And realistically, Jupiter will have around 60 plus individual moons. So if you imagine here on planet Earth, we only have one orbiting satellite, we only have one moon. But if you imagine Jupiter to have that number of moons, that must be a fascinating view if you're able to stand on the surface of Jupiter. It'd be absolutely stunning. But for now, I'll focus on the four main moons. The Galilean moons, so you guys might have guessed from earlier in my talk, they were discovered by Galileo. So when you're looking at these objects, you are seeing the same view as Galileo did back in the year 1610. It's beautiful. So those moons are known as Io, Europa, and Callisto. So those are the four.
Oh, I need to go to the bathroom. So
sorry, guys.
I'll get my head.
Just to make you aware, but I can hear. I believe there's some audio, just to make sure that everybody's muted. Just to continue on. Thank you very much. So we've got Io, Europa, Ganymede, and Callisto. So just make sure to remember those four main moons. And opposition, which is when we'll be able to see Jupiter at its best this year, will occur on the 19th of August. So if you were to look at Jupiter now, this is the current view which you'll be able to see. So when I talk about the Galilean moons, you'll be able to see these individual satellites just to the side of the planet Jupiter. And again, this is a rough simulation of how astronomers like myself are able to observe the planet Jupiter. So it is a bit of a difference, and some of you may have seen this as a shock when I show you the images from NASA to the actual view you're able to see through amateur telescopes. So you have to remember these images are taken with the likes of the Hubble Space Telescope. And I wish someone told me this when I was younger, because I thought, as soon as I get a telescope, this is the view I'm going to see. But I think it's really important to reiterate, because of the level of professional astronomical telescopes being used, the size of the mirrors depends on how much detail we can see. So remembering that Hubble, because it's orbiting around our planet, it doesn't have the effects of the Earth's atmosphere. It's out in space. It's a pretty big telescope. We can see all of this beautiful detail. But you have to remember, when we're observing these objects from planet Earth, the view will be slightly different. So this is a rough view of how we will see the surface features on other worlds, like with the planet Jupiter. So moving on is another favorite of mine. The planet Saturn. This is one of the most iconic planets of them all. So I'd like you guys to try and guess why this is one of the most iconic planets. So we've been looking at mainly rocky objects, and we've seen the biggest planet in the solar system. But the main reason people are drawn to this beautiful planet is because of its obvious large ring system. And honestly, it's a beautiful object to look at, which is basically constituted of chunks of rock and ice. And in doing so, from the formation of this particular planet, the planet Saturn, during the formation in the early solar system, objects of rock and ice have begun to orbit around the planet. And here in this image again, we're able to see the varying ring system. So if you look real close up to your screens, guys, you'll be able to see the individual ring systems. So already that is fascinating to look at. So already, just to talk about what we're looking at here, Saturn itself is a ball of hydrogen and helium. That is the most basic way to put it to you guys on a basic level. So if you forget the rings for 1 second, when you're looking at the planet Saturn, you are looking at a ball of hydrogen and helium gas. So as lovely as it would be to stand on the surface of Saturn and look at its beautiful ring system, its moons as well, which I'll get onto in just a minute, we may not be able to do that because it's another one of the gas giants. So moving on through this, the visibility of Saturn again is another really good object to see. It's a bit dimmer than the planet Jupiter for obvious reasons, being the second largest planet in the solar system. So again, you're able to see currently Saturn at a magnitude of +70, so 0.70. So it's on the verge of what would appear like a star in the night sky. But if you use optical aids such as telescopes again, you'll very easily be able to identify that this is no normal planet that we're dealing with here. You'll be able to see a slightly elongated shape. And in doing so, when you look at this planet, you're seeing its rings. You are seeing the planet Saturn, one of the iconic stellar objects which so many people have always wanted to see. So Saturn itself, you're able to see on the 2nd, from around the 2nd of August to December the 21st. Now, I've selected these dates because this is around opposition. So again, if you guys are taking notes in your diaries or on your computers, you want to be looking from the 2nd of August, because this is when Saturn will be at its closest to Earth and will be able to see as larger a larger view of the ringed world. So this is when we're able to see these finer details. But if I can draw you guys closer to your screens for just 1 second, there's a couple of very interesting features which you can see on Saturn. So you might just be able to see highlighted by my mouse, you see this relatively dark line, or this ring rather. In fact, this is a gap in the ring system, and astronomers and astrophotographers have been able to capture what is known as the Cassini division. So this is a recognized astronomical feature called the Cassini division. So this is the division between the A ring. This is for those who are a bit more complex in astronomy. The A ring is the inner rings and the B rings are the slightly outer rings. So this is just a rough way of looking at the basics of observing Saturn. Now, if you look very closely on the top of the ringed world Saturn, we can see what is a famous weather feature which resembles a hexagon. It's a very unusual symmetrical weather feature happening at the North Pole of Saturn. And again, when you see images from voyage expeditions such as Cassini, we've seen some beautiful images on the surface details of this planet, on the planet Saturn. So again, some of the major moons to look at, again, Saturn has loads of moons, I must reiterate that. But 2 of my personal favorites are Titan and Enceladus. So we'll go into more detail about how you can find out more about these moons if you wish to do so in your own time. And I have some resources to show you at the very end. So again, this is just a rough simulation again of how you'll be able to see the ring world Saturn. And what's really interesting, when I first observed Saturn when I was 7 years old, I remember seeing the ring system when pretty much Saturn was side on. So when I had all these hopes and dreams of being able to see the ring system, which was Saturn, I was quite disappointed actually, because I couldn't see them for a number of weeks. Because the rings rather were edge on during its orbit, I wasn't able to see them. But again, it's a very important thing to recognize that over an orbital period, that you'll be able to see the ring system open and close. So I think this is just a fun little activity for everybody watching. Can we bring our hands together, please? So we have our hands, if we can bring them together, we can see how the orbit of Saturn will change. So you've got to remember now that when we were seeing Saturn at its best, the rings are really wide open. But now gradually the ring system is beginning to close ever more and more and more until eventually we'll see them side on. And this is gradually what the planet Saturn is doing at the minute. And as you guys might have noticed whilst I've been talking about weird, strange things with my hands, is that you'll be able to see some of the moons as well, including Titan, Hyperion being another one, Tethys, Rhea. These are just some of the other moons which you can observe. But for the purposes of being basic in this workshop, I'll stick only to the basics. The planet Uranus. Now, this is a really unusual planet because it is the only planet in the solar system which has an orbit on a 180-degree angle. So some astronomers believe that this particular planet was knocked off course during the early evolution of the solar system, and in doing so orbits at a very unusual angle. So one of the characteristic features which I think is important to remember now is we're going into the journey on the outer edge of the solar system. We're looking at the ice giant. So we're seeing masses of hot, dense fluid and icy materials as well, including water, methane, and ammonia. So this is really what gives Uranus this characteristic, slightly eggshell colored surface. But again, it's a very interesting planet to look at nonetheless. But I'm going to say now, though, it is possible to see the planet Uranus with your unaided eye, but I strongly recommend, if you want to see any surface features whatsoever, you will need to use optical instruments. So I think this is where now we're beginning our journey from using our unaided eyes to optical instruments. But again, please use the Q&A tool if you guys have any questions whatsoever. If you guys are thinking, what telescope do I need to observe these? How big a diameter do I need? What eyepieces do I need? Honestly, if these are puzzling your mind, please let me know in the Q&A chat, guys. I'm here to help. That's what I'm here to do. So again, a good time to look for the planet Uranus will be between the 8th of August to the 31st of December. So this will be a time to observe Uranus during the evening. So the opposition itself, so this is again, the closest approach to Earth, will occur on the 4th of November. So some of the major moons to observe will be Umbriel and Titania. So there's a couple of moons which are visible through telescopes, but as I said earlier, you need the big guns really to be able to see those. Now, as I mentioned also in terms of brightness or magnitude rather, we're seeing that the magnification is getting dimmer. So we're getting higher into the plus figures here at plus 5.82. So that's why I reiterate really that you need optical instruments to observe this world. This is an image by NASA, by the way, but in realism, you're going to see something much smaller than even this simulation on the screen, because we're looking out to the far edges of our visible solar system. So again, some of the moons which we're able to see, which I mentioned earlier, Titania, Umbriel, Ariel, Miranda, which can be observed with these larger instruments. Now we are nearly on, I'll say nearly for an obvious reason, we are on the edge of our solar system, ending with what I think is one of the most striking planets in terms of color, which is the planet Neptune. Again, is another ice giant which has materials of water, methane, and ammonia, but I believe are much stronger on the planet Neptune, which gives it this rich, vivid blue color. But again, we are looking at another stormy world, and that is what I think is so interesting to observe on this particular planet, because as you can see in this image by NASA, is a very large dark blue storm feature, which astronomers have observed for years, and we can see the gradual change throughout the years, especially on the planet Neptune. So I've classified the visibility of Neptune as a telescope-only object purely because of its magnification. As you guys have seen from the planet Uranus, look how the magnitude has increased to nearly magnitude 8. It's gone beyond what we can see really with naked eye visibility. So you need a telescope if you want to get that really rich blue color. A good time again to look will be from the 19th of July through to the 8th of November in the evening. So it's a nice good time to observe it for you guys. And please ignore the moons, because I've just realized that I have currently used the moons for the planet Jupiter. So please excuse me for that slight grammatical error. But again, the opposition will be best observed on the 14th of September. So if that's another note for you guys, or if you want to talk about it with me at any point, then please do, of when is the best time to observe these objects. And again, the surface of Neptune, a very small object to see, and using high power telescopes and eyepieces, will we be able to see any structure at all on the weather phenomenon on the surface of the blue planet, the planet Neptune. I've left the end of the solar system now with a highly controversial object. So the planet Pluto was once believed to be the last planet of the solar system. However, it's been classified recently that the planet Pluto has now been recognized as a dwarf planet. And I must leave this one open to debate as to whether you guys should believe that the planet Pluto should remain as a planet or still be currently classified as a dwarf planet. A dwarf planet, guys, basically is a really, really small world. So hence the reason dwarf planet used in astronomical research. And here again is one of the recent images captured of the planet Pluto, I'll say for now. And really, again, it's such an interesting object to observe because it is a cratered world full of different deposits, which you can see in the varying colors and shadows and highlights of this world. But what I think is also really interesting as well is that there's a feature, a phenomenon on the surface of Pluto, which resembles a love heart. So if any of you guys for Valentine's Day wish to show someone a beautiful planet to look up to in the night sky, show them the love heart on Pluto. It's a beautiful planet to see. However, I must reiterate again, this object is so small, even through an optical instrument such as a telescope, and will appear like a star, what we would see in the night sky, but through a telescope. So again, this is just a simulation for you guys, just to get a rough idea of what you could expect to see through now more professional astronomical equipment, such as the Hubble telescope, but realistically, you'll be looking at a pinprick of light if you guys were to observe this planet. So now we're going near to the end of my talk. So it's near to 7:45. And again, I just wanted to show any new members to Space4All some of my personal go-to astronomy books. These books are really good if you guys want to find out exactly where these objects will be in the night sky. So during this talk, I've given you a rough idea of when you'll be able to see these planets. However, Phillips' 2021 Stargazing, written by Heather Cooper and Nigel Hembest, is a really good resource, guys. Make sure you buy it after this talk. Get a reserve on eBay. It is so good and breaks down through the months. And you'll be able to see what planets are best suited in the night sky throughout the months. And also Stars and Planets, a book which I got, again, at the age of 7 years old, the Nature Guide, Stars and Planets, which was literally my Bible to looking up at the night sky, which teaches you not only the constellations and the planets, but also deep sky objects, such as galaxies, nebulas, and celestial events. So for any of you guys who are, again, looking for some beginner resources, these are some good ones to look at. But again, for those of you who have been following me so far in my astronomical journey, here's a couple of other resources for you to look at. So one of my good friends, Will Gator, released an amazing book called The Practical Astronomer, and it really is a good resource. It's a bit more expanded on the Stars and Planets book, which I just showed you guys recently, but it goes into a little bit extra detail for the amateur astronomer, and will be able to tell you when is the best time to look at the planets, but also has some really good external links or resources to identify these planets. Now, some of you may remember my background, but for a very short amount of time, I used to work on BBC's The Sky at Night. So this is a book which I can personally recommend from one of my previous colleagues, Dr. Marguerite Agerin-Pocock, and is a book which I used to hold for, I still hold for a long period of time. And it's a great resource to read into more of the geological structures of other worlds and really understanding the geology of these planets. So again, if you like to read the work of Maggie Agerin-Pocock, it's another brilliant resource to look at. I've mentioned this in my previous talk, but again, I think will give you guys a much more greater feel of how to identify the planets and exactly where by using online planetary software or astronomy software. So again, some good resources being Stellarium, which you can get or use online as a free software. You can use a paid for version, which gives you just a bit more extra information and resources. But another one, again, which I used to use, again, when I was a youngster, was Starry Night. So it's a really good resource for building a virtual planetarium, which will be able to tell you guys on what is visible in the night sky tonight. This is just a screen grab just to demonstrate what we're able to see tonight. So if it was clear, I had my camera set up and I could show you guys the stars live currently I would be able to show you the planet Mars and the planet Uranus, which is very closely placed in the constellation of Taurus, which we discussed in our last workshop, but also is very close to the open star cluster currently known as the Pleiades, also known as the Seven Sisters. So when we eventually, guys, get a break in the clouds, make sure to take a look for the planet Mars and the planet Uranus. Just remember, in case you guys are beginning out in your astronomy journey and you need to know the basics, I have my constellation cards if any of you guys need help learning the constellations, but remembering the constellation of Orion, the constellation of Taurus, and the Pleiades, and it'll be very close to there. So when we're looking at a reddish object in the night sky, very close to Taurus, we're looking at the planet Mars. So this is just to give you an idea of what we can currently see in the night sky and how virtual astronomy software allows us to project what we can see in the heavens. Now, this is a really useful resource, guys. I only found this out myself a couple of months ago, but it's a piece of software launched by NASA and JPL, which is a solar system simulator. So for those of you who want to say, I want to see the red spot, I want to see the rings at a particular angle, or you want to see any surface features like on the red planet, you can use this software to roughly locate what day and what time you want to see these objects. So just to break through very quickly, show me is really the planet you want to look at. So for example, we'll take Mars. So where it says Saturn, we say, okay, go down from the list, we select Mars. And of course, you want to see this planet from Earth. There's no point trying to observe this, particularly from Venus. You want to be on Earth if we're to use telescopes for now. So make sure you've got Earth selected. And from here, you're able to select the month, the year, just bearing that in mind. So you've got your date, your month and your year, and the time. That is most crucial, guys, if you want to look at objects or features specifically. And again, you can choose how you wish for the field of view. We'll go into this feature a bit later on in our workshops gradually, but it's really how we use eyepieces to give us that field of view, or that enlarged image, we'll call it, of a planet. But when we take up all these bits of information, we're able to simulate what we can see currently on other worlds. So this is how, as I've shown you throughout this presentation, we're able to see the planet Mars. So again, it's really interesting software to use, and it's some really good software to use, guys. So make sure you take a note of this. Okay, so that brings me to the end of my talk on the planets during current lockdown restrictions. So I just want to say thank you very much so far for those of you who have watched my presentation. And this is just a breakdown of the Space4All virtual calendar for 2021. So we have covered the constellations and today the planets. So as you can now see, we'll be looking at the moon. So this will be our next feature and how we can observe the lunar seas and the craters on the surface of one particular place in our solar system where men have once stood on the moon. And I hope to show you guys the rough locations of where we're able to see the Apollo landing sites. So that will be on Thursday, fingers crossed, Thursday, the 25th of March at 7 o'clock. I must admit, guys, I was supposed to be doing this workshop actually tomorrow. However, I've got some light pollution work, which I'm doing then, so you have to excuse my change in dates ever so slightly. But if you guys would like a copy of my calendar, please send me an email or leave just a comment in the Q&A below, and I'm more than happy to provide you with a copy of the calendar. And also, this workshop wouldn't be complete without a few takeaway aspects. So these are some planet cards which I've created for you guys. So if you guys want to look up at any objects and you want to get an idea of what to see in the night sky, please send me an email joshjuryphotomedia@gmail.com, otherwise space4all uk@gmail.com, and I'll be more than happy to send you some planet cards. So again, talking about some of the surface features which we're able to observe on these distant worlds, but also to visualize what you may be able to see through a telescope. So I'm more than happy to send these to you guys. Just please let me know if you'd like a copy of these. Again, the way this is going to work, guys, I'll need your help. So we need to, in order to grow Space4All and to get more of us interested in the night sky, please make sure to follow us on social media, if you have it, on Facebook, Twitter, YouTube, and Instagram at Space4All UK, where you can keep a bit more up to date with some of the upcoming workshops. And also, please recommend this, guys. If you've got anybody who may be interested in casual astronomy, stargazing, looking up to night sky, or wants to know anything in particular, please recommend them to join our talks, because that is what I'm here to do, is to inspire as many of us to look up at the night sky. So again, also another resource is on our YouTube channels. I have some planetary videos, including the recent opposition of Mars, for you to take a look at in your own time, and hope to be making a few more of these videos when I can, really, whenever there's a clear sky. So please make sure to keep tuned to that as well. It's also worth mentioning, if you guys want to watch this workshop again, I will have this on my YouTube channel, my Josh Jury Photo Media channel, which you can view again. Otherwise, I will be sending or uploading this video on the Space4All YouTube channel. So if you guys want to watch this particular workshop in your own time. So I will now begin opening the chat. So let's have a look. Let me just diminish my screen so I can see what some of your guys' lovely comments are. So just give me 2 seconds to do so. Okay, so if I just get this sorted 1 second. And we'll stop this share for now. Okay, lovely. Let's have a look at the chat. Right, okay, so we've got quite a few questions. So I'll begin from the top. So one was sent directly from iPhone. This is quite random, but do moons have more of a circular or elliptical orbit? So I'd just like to say thank you very much for your question. And really, it depends on the planet in question. So when you have elliptical orbits, this resembles a more egg-like shape. So if you literally imagine an egg and you get that unusual shape, really, that you'll be able to see the changing orbit. So this is when particular objects within our solar system will appear further away at times, but also very close, which is at times like opposition. So I think the best way to answer that more specifically is that planets are much more elliptical in nature, but again, it depends on the object in which we are observing. So thank you very much for your question. So the next one, Martin, is the Stellarium app accurate, useful tool for finding where stars are in the sky on any one day? Do you know of a better one? Okay, so thank you very much, Martin. The best way I can describe that is Stellarium is accurate. Again, the only thing I'll need to say is you'll need to know what time you're observing. So the best way I can say this is when you're going outside and you have your clear sky, you look at your phone and it says, okay, it's 8 o'clock. Put an 8 o'clock in on your phone and the date. So realistically, it should be showing you a live view of how we can observe the night sky and create a virtual planetarium. But otherwise, as I've mentioned already, Starry Night's quite good. But again, you can get physical planispheres, which are able to show you some of those major constellations. So another question, just thank you very much for that one, by the way. Dark Skies, MSAS. The Philips Stargazing Guide is available from The Works for just £3. It's a really good guide. So thank you very much for your comment there. And again, this is just a really important thing to realize, that resources in astronomy are not expensive necessarily. They are really good. So And I've just seen Martin's response. So yeah, thank you very much. Just answered my question. Great. So Phil, interesting factoid. Oh, hold on. Excuse. Interesting factoid. The parachute used on the Perseverance Mars rover to slow its descent was made by Tiverton, Devon by Heathcote Fabrics Limited. Way, supporting the West Country. That's really good. Martin, I'd like a copy of your Future Talks programme. Not a problem, Martin. I'll make sure to send that over to you. And just to say thank you very much for Dark Skies again. Steve Green. Okay, so any chance for recommendations for telescopes? Okay, I knew we were coming up to this. This is great. So like everything these days, it's a bit of a minefield. It is so true. I will go into a proper talk on telescopes, but I personally recommend, this is just my own personal view, okay? There's 3 types of telescopes. We'll go into this in another talk, but very briefly. We have refractors, reflectors, and Cassegrain telescopes. So refractors are the very traditional types of telescopes that we see associated with astronomy, where you have an eyepiece at one end and you've got the optical element at another end. They're okay to a certain extent. However, you get an optical feature known as chromatic aberration in the larger object or the larger instruments you get. So myself personally, I'd cancel out not getting refractor telescopes, but I'd go more towards reflector telescopes. The reason why is they are so much more affordable on the astronomical market. And again, for observing the planets, this is something I have to reiterate. You want a telescope any bigger than 4 inches in diameter. So you have to remember the diameter of mirrors is all to do with light gathering. So the more light that we have coming into our telescopes, the more details we're able to see in terms of the planets. So already it's very interesting, really, that you have to use loads of different types of telescopes to observe different things. Sometimes you want to be using refractors to observe deep sky objects where you've got a much wider field of view. Whereas if you use reflectors and Cassegrains, you're able to create much more field of view using your eyepieces, Barlow lenses, whatever that may be. So again, is another really good bit of knowledge for you guys if you're wondering. Cassegrains, they're much more compact in design, and it's all to do with the amount of mirrors that they've got inside of the tube. So they're very compact, really good in design. And again, you can get those in some good sizes. So it's all depending really on the kind of way you want to use a telescope. Do you want it permanently set up? Do you want a telescope for on the go? So again, there's all these questions to think about. But again, if you guys need any help at all, please send me some questions after the presentation, or even now if you like, if you guys want to continue on the talk. So again, I hope that's helped your question there. And just had some really lovely comments. And just to say thank you very much for everybody saying it's a lovely informative talk, and also to have some support from Dark Skies as well. So thank you very much for having me there as well. And really now's the time that I'll give anybody to leave, or well, what I'm trying to say is if they like to unmute themselves, sorry, if you like to unmute yourselves, please do so, and I'll be more than happy to answer any of your questions. But otherwise, we have just got a question from Pippa. When you're starting out with your first telescope, get one that's easy to set up, and very true as well, because honestly, with more sophisticated telescopes, they can be a little bit tricky to set up, but I'll go into that in another workshop as we develop our knowledge together. But if it's brilliant, but you do not use it because it's too complicated, then it's not a good telescope. Very true. So you want to start off with something basic, and this is the point of these workshops, guys. You want something which is basic. So anything really of different brands of basic telescopes I can think of: Celestron, Meade, Skywatcher. Again, there's some really good brands of starter beginners telescopes. So where you have less things to carry around is a lot more practical and better. So again, it's all dependent on exactly how you want to use a telescope, really. For example, my telescope, I personally own an 8-inch reflector telescope, which for me is a good enough size to observe some of the deep sky objects, the planets. I chose a reflector really because it's a bit more affordable in the astronomy market, and again has about 1000 millimeter focal length, which I'll go again to you guys into much more information in our next oncoming talk on telescopes, but basically allows with eyepieces to produce a much larger image of the planet. So that's a good reason why as well. And I've just had another question from Phil. Are you going to cover astrophotography in a future workshop, Josh? Of course I am. I'm an astrophotographer, so I will be showing you the basics on how exactly to take photographs of the night sky. And I'm really hoping that I'll be able to do a real-time setup with you guys where I'll be able to physically take photographs with you, looking at the stars, but we need a clearer night. That's what we need. So that's my intentions for this group when the weather's right, so we don't have to necessarily do virtual workshops as such. We can have more of an interactive environment. So again, some more very positive comments coming in, just to say thank you very much. So really, again, is now a good time. If anybody would like to unmute themselves, if they have any questions, I will allow you to do so. And I will allow that now.
So, Josh, just to say, one suggestion for an observing project is to observe Jupiter when it comes next summer. Observe Jupiter even with just binoculars, and do sketches of where the moons are, the position of the moons. So you can. It's like following in the footsteps of Galileo. It's great fun, and I think it develops your observing skills as well if you're a new observer, because you really get used to sort of focusing on what you're seeing, sketch it out, and you can actually see the differences between the four moons, their brightness, because they're quite significantly different in brightness. And then as you do that each night, or if you're really brave, stay up all night and watch them move around the moon, just like Galileo did. It is great fun and really informative and helps develop your observing skills too.
That's brilliant. Thank you very much, Hugh. So for just some of you guys who don't know Hugh, Hugh's a really good friend of mine who's a fellow local astronomer, and a very good piece of advice as well, being able to illustrate the planet Jupiter and the Galilean moons. So some of you guys may be interested in creating a journal of being able to observe some of the major planets of the solar system, so that night on night you're able to draw, say, the planet Jupiter, and every night you can see the positions of the Galilean moons change. And as Hugh very correctly said there, you'll be able to basically document exactly what Galileo did all those years ago. So then again, that's another really fun activity to keep us looking up at the night sky. So thank you very much, Hugh. And would anybody else like to unmute themselves if they got any questions? Would like to say hello to the group at all? But otherwise, if people are a little bit camera shy or have their microphones turned off, that is honestly not a problem, because I tell you what, guys. Hello, hi.
Hi, Josh, it's Steve.
Hello, Steve. You're right.
I don't know who it was that said last month about actually going out in the night skies when they're not totally dark skies, like I was asking in Wells, that you can't see all the stars out there, which will help you identify the brighter stars in the sky without the clutter of everything else in the background. And the evidence of that worked really well for me was I could go out there and see certain stars with my eyes, but when I started taking photographs, the sky was full of stars, which I couldn't see with the naked eye. So, and I think it was really good so that I could see those formations and shapes in the sky of the stars that we know of out there without the clutter of all the rest of it in the background, which I think if you go to a much darker area, you would have trouble to find those.
Yes, that's a very good comment, Stephen. Thank you for that as well. So again, this relates to terms of magnification. So just in case you guys aren't aware, but when you take long exposure astrophotography, the lens acts as your eye. So when the lens is open to more light coming into a camera, effectively it will be able to see more stars than what we can see with our unaided eyes alone. So again, a very valid comment from Steve there, in being able to see many more stars. And honestly, I've been to some dark sky sites, and I think the best example was the Atacama Desert in Chile. Honestly, I remember taking one image of the Milky Way as seen from the southern hemisphere, and already that was enough stars. I couldn't even recognize some of the southern constellations because there was just so many stars. But when you took images of the night sky, you couldn't even see the constellations at all. So again, I think that's a really important feature to reflect on. But also when you're taking images again, because of light gathering, we can see some of the deep sky objects. In this, I mean galaxies, nebulas, and star clusters. And I think one of the more classic examples for me is the Horsehead Nebula, which is visible in the constellation of Orion and has a lot of red color emanating from it, which is hydrogen alpha gas. So when you try and observe this object in particular, even through a telescope, you need a really large diameter telescope to do this. And even then, you won't be able to see some of the color. But it's the fact that when you take a photograph of one of these objects and you've got more light gathering coming into your camera, that we can reveal this color, which is so important to reflect on. So again, that was a very valid comment. Thank you very much. So otherwise, would anybody else like to mute themselves? Otherwise, I just want to say, oh,
Josh.
Hello, Phil, are you all right?
Hi. Yeah, fine. Josh, do you know if the Dark Skies Festival on Exmoor is planning to go ahead, COVID allowing, of course, at the end of this year? Do you know?
Right. So from what I've been doing with the International Dark Sky Association, Phil, I haven't heard anything as of yet. However, I believe that information would be published probably during the middle of the year. I can remember, especially from last year, like, you know, with the way 2020 was, most of last year's events were virtual programs. So I would believe in relation to government guidance as our only indication at the minute that it could well be a scheduled public event. So we'll just have to wait and see how the vaccination rollout is at the minute. And this may mean that virtual workshops will be a thing of the past for us here as too. So again, that would be really good to do some more public meetings as well. So in answer to your question, Phil, I believe more strongly with the way the current government guidance is, then yes, it could well be scheduled as a public event at the end of the year. Thank you very much.
Thank you.
But again, I just wanted to say it's been so lovely seeing all of your guys' faces, and I'm aware that it is 8:15, so I'm sure you guys want to have your tea or enjoy the rest of your evening now. Thank you. So I heard you on there. Just to say thank you very much to everybody who supported my most recent workshop with Space4All. So just to remember that our next meeting will be next month, where we'll be looking at the moon. I will be keeping you guys up to date. If you want to join my mailing list for Space4All, please send me an email and I'll add your email to that if you haven't already. Please follow us on social media, Facebook, Twitter, Instagram, YouTube, to keep up to date with all the mad, exciting things that we're doing. And most of all, guys, it's so lovely to see your faces and that you're all staying safe and well. So on that note, I'd like to say to all of you guys, stay safe until next month. And I'd like to wish you guys clear skies and all the best. So on that note, I'll let you guys leave when you'd like to, but just to say thank you very much. And I enjoy to see you guys next time at our next virtual workshop for Space4All. Bye for now.
Thanks very much.
Bye. Bye.